So today we solve rest of the numerical of machine chapter part A. Okay, here the question number 8. Okay, previous class we solved question up to question number 7, and today we start from question number 8. Okay, now a lever of length 9 centimeter has a load arm of 5 centimeter. Okay, so long and effort is 9 centimeter long, and which to which the class goes it belong. So first we try to draw the diagram. Lever length is 9 centimeter. Lever is 9 centimeter long, means that length is 9 centimeter, and load arm is 5 centimeter. Suppose here to load arm, suppose that is the 5 centimeter. Okay, and here the effort arms is 9 centimeter long, means that's the 9 centimeter is effort arm. That's the effort arm. That is a load arm. Okay, so fulcrum points thing here. That's the fulcrum points, and here the load, and here is effort. Okay, so very easy question. That is fulcrum is one side of the lever, and load is situated here, and effort also situated here. So that is a belongs to class 2 lever. That's a simple, the basic, that is the class 2 lever. Next, now the diagram of the lever showing the position of the fulcrum point, direction of the load and effort. That's a direct question, easy question. Okay, so here that's the part B answer, the diagram. Okay, now what is the mechanical advantage and velocity ratio if efficiency is 100%? Okay, so we know the mechanical advantage. Mechanical advantage equal to load over effort, and also effort arm by load arm. Here the given is effort arm and load arm. So mechanical advantage, effort arm is 9 and load arm is 5. So suppose 9, 5 times 5, 4.0, 1.8. So 1.8 is that mechanical advantage. Okay. So if the 100% efficiency, so we know that formula from previous lecture. We know that the relationship between the mechanical advantage, effort arm and load arm. I think we found here. Okay, derive that equation. Okay, eta times VR equal to MA. So eta times VR equal to MA. If eta is 100%, so obviously 100% means 1. So that is VR equal to MA. Okay, so very simple. So velocity ratio also VR equal to 1.8 if 100% of mechanical 100% efficiency. Okay, now next question. What will be the mechanical advantage is the velocity ratio if the efficiency becomes 50%? Okay, that's a tricky question. If efficiency becomes 50%, now efficiency 50% means 1 by 2 times VR equal to MA. So VR by 2, that is also equal to MA. Okay, so VR equal to 2 times MA. If VR equal to 1.8, that is 2, and that is mechanical advantage. So here the mechanical advantage equal to 1.8 by 2, cancel out, that is 0.9, limitless. Okay, so mechanical advantage is 0.9. There's answer number D. Very easy question. Okay, Now, question number 9. Okay, so here the diagram. So first we put a diagram here. So the given diagram is like diagram in that question. So effort, here load, here fulcrum point. If okay, first question: to which the class of lever does it belong? Very easy question. Okay, basically, if load is between the effort and fulcrum point, so that is belongs to class 2 lever. If A is 80 centimeter and AB is 20 centimeter, okay. If FA is what is the mechanical advantage? What does it mean if A? I think that is FA. I think that is FA should represent not A point here. Actually, like this FA here, like this B. So FA means that is belongs to 80 centimeter, and that's AB is 20 centimeter. Mm, So, great question. What is the mechanical advantage? So we know that from previous question, mechanical advantage equal to effort arm by load arm. So here effort arm is 80 centimeter or effort to fulcrum point, and here the load arm. That's important point. Load arm is that here to that one. That is 80 minus 20. That is 60. So that 60 0 cancel 4 3 4 by 3. Okay, that is the mechanical advantage. That's the part B answer. And part C, calculate the value of E. I think load is not given here. Okay, so mechanical advantage equal to load over effort. That is effort arm by load arm. That is I think 4.3. So load is not given here. Let's assumption is load equal to suppose 2 kgf. Find the value of E. Suppose let's say not given here, so we say that load is 2 kgf. So that is 2 by E. That is 4.3. 2 to cancel 2. So effort equal to 3 by 2 means 1.5 kgf. Okay, that's the part C. Now, here's a question number 10. Very easy question. And question number 10, number 10. Okay, here is a figure. Figure show the wheel and borrow. First, you try to draw a diagram from books. Okay, wheel. Okay, the diagram is given in that question. Okay, that is point C. A cart. Like this. Yes. Okay. That is point B point. Mm, okay. From that's A, and that length is 20 centimeter, and that rest of the length is 40 centimeter. I think that's 40 centimeter. Okay. Now AB also given and AC also given. Okay, that's A and C. Okay, so if load is 30 kgs at with the center of gravity at A at point B and C, the center of the wheel and tip of the handle such as the horizontal distance of AB and AC. Okay. Okay. find a load arm. Easy question. If that is a fulcrum and here is that load, so that distance is load arm. Very simple. That is a load and that is a fulcrum, that is a load arm. I think answer A. What is effort arm? Effort arms belongs to from fulcrum to effort. That is effort. So that length means here that length. So effort arm is 20 plus 40, that is 60 centimeters. And now number C, what is the mechanical advantage? Very easy question. The mechanical advantage equal to effort arm by load arm. So here the effort arm is 60 centimeter and load arm is 20 centimeters. So that is the mechanical advantage is 3. Okay. Number D is the minimum effort required to keep the leg just off the ground. The minimum effort required. So here question number D, the minimum effort required to keep the leg is just off the ground. Okay, that is a very easy find effort. So here the wheelbarrow of mass 15 kg carrying a load is 30 kgf. So load is 30 kgf and mass of the wheelbarrow is 15 kgf plus mass also here. So mass also 15 kgf. Okay, the total load is that is 45 kgf. So mechanical advantage equal to load over effort. We know that mechanical advantage 3. So load is 45. So effort 3 times 15. So effort equal to 15 kgf. That's the correct or easy answer. Next, question number 11. Here's the diagram. Okay, here is the diagram. Okay, so first we draw the diagram. Okay, here is a fixed point. Okay, here the effort A, effort at point A, load at point B. Here the load. Okay, and load is 50 Newton. Okay, so state the principle of moment as applied to the above lever. Okay, so what is the principle of moment? We know that load equal to load arm, load into load arm. So is load into load arm and effort times effort arm. That's the principle of moment. Okay, next, to which the class of lever does it belong? Load one side, fulcrum is here, and effort is middle. That is the belongs to the class 3 lever. Okay, very easy. Class 3 lever. Now if FA is 10 centimeter, that's a 10 centimeter. AB is 490 centimeter. What's the mechanical advantage? So mechanical advantage equal to effort arm by load arm. What is effort arm from here to here? Effort arm is not. Effort arm is here to here. From fulcrum to effort. That is 10. And what is load arm? Load arm is here to there. That is 490 plus 10. That is 500. Cancel 1 upon 50. That's a mechanical advantage. What is the minimum effort required to lift a load of 50 Newton? Okay, that is equal to load over effort. That is mechanical advantage 1 by 50. So load is given 50 Newton. So that is 50. So 50 by E 1 upon 50. So effort equal to 50 times 50 means 2500 kgf. I think, sorry, not kgf, here is Newton. Okay, okay. because here the given that is a Newton unit, so that's a Newton. Very easy question. Okay, next question number 12. Okay, a fire tongs has an arm length of 20 centimeter long and is used to lift a coal of weight 1.5 kg by applying an effort of distance 15 centimeter from the fulcrum. The length is 20 centimeter. Okay, total length is 1.5 kg. The load, and here we can apply effort. Okay, so effort from the distance 15 centimeter from fulcrum. So I think fulcrum point is here. It means 15 centimeter. Okay, so what is that load? Load is like belongs to this. That is a load. Okay, load arm. It is the effort arm. So mechanical advantage equal to effort arm by load arm. So effort arm is 15, load arm is given 20. So 3 by 4, 3, 0, 4, 7 is 28. 0.75. Mechanical advantage of fire tongs is, sorry, 0.75. Okay. Next, what is the effort needed? Very easy question. Mechanical advantage is 0.75. That is load over effort. Load is 1.5 kgf by effort. So effort equal to 1.5 of 75, 100 point from 10, 0, 0 cancel, 5, 15, 5 to 75. So 5, 2. So that is only 2 kgf. That's the answer. Very easy. Okay. So we end that all numerical from cellular physics class 10. Next class we start pulley. Okay. So if any doubt in that numericals, ask put in comment section. I will try to give the answer. Thank you.